My dear friends, hi. Warm welcome to another evening. Actually, there happened a technical error, so that the connection got lost. I lost my connection, so that I'm trying to explain everything from the outset itself. Consider this to be a fresh video. See, today I'm going to discuss something really important, which is related to um, laws of motion, equations of motion, friction, and this is I'm going to discuss a question which is having a several cross concepts. Okay, actually, why I'm trying to discuss these questions today? Question today is one student from my community. She asked a question, or she shared a question with me last day. So she has been preparing for the Olympiads. She's in class 9th as of now. She's a diligent student, very interested in her learning. She wanted to solve a particular question which is related to the concept of friction. So I went through the question and I found that the question is rather really difficult for a 9th standard student to solve. Why it is difficult? Because there are at least 4 concepts which are not familiar for a class 9 student. And the question is appearing for a competitive examination like Olympiad. Okay. So I wanted to discuss the same question in the +1 live session today. It is because most of the concepts needed to solve that particular question comes in the +1 syllabus. Okay. So I really wonder why these people set these kind of questions to a 9th standard student, even without giving the primary idea of the concepts. So I would like to say that our broken education system is creating no enthusiasm, no excitement for our students to learn the topics. It only caters, or it only forces our students to mug up the information, and also they are relying on some rote memorization techniques. And due to the same reason, a subject, beautiful subject like physics, the students are really getting frustrated with such a beautiful subject like physics. So let me solve the question first, and then I will discuss the gaps and cracks related to that particular question being pushed to a class 9 or class 10 student. We will discuss both things in this particular video, and let me share the screen with you. Okay. Now I wanted to read the question first. Read the given passage and answer the following question. Rishi places 2 boxes X and Y. Okay. 2 boxes X and Y of equal mass. That means the given thing, let me write it here. Mass of X is equal to mass of Y. It is given. So that we can write simply as M. Equal mass, and releases them simultaneously. So on a rough inclined plane as shown in figure A. This is figure A. Okay. So both X and Y are released. What does it mean? Released means their initial velocity is 0. They are released from rest. Okay. Now, initially the box X is √2 meter behind box Y. It is clear from the image. The box X is √2 meter behind Y. After some time, both the boxes are in the same line as shown in figure B. See, after some time, both X and Y reaches the same line. Then another information given is coefficient of friction for the box X and Y are 0.2 and 0.3 respectively. So coefficient of friction for X, mu X, it is equal to 0.2, and coefficient of friction for Y, it is equal to 0.3. This much of data is given here. Now, the question is, which one of the following statements is correct? Option A, at time t is equal to 4 seconds, both the boxes are in the same line, which means they are saying that when the boxes reaches at this line, time t is equal to 4 seconds. That is the first statement. Now, second thing, at time t is equal to 2 seconds, x has traveled a distance of 7 root 2 meter and y has traveled a distance of 9 root 2 meter. That is the second statement. And the third statement is like this. At time t is equal to 4 seconds, distance traveled by both the boxes is 8 root 2 meter. Both the boxes is 8 root 2 meter. We can discard that option upfront. Why we can discard that option upfront? It is due to one reason, because here both x and y are not having the same friction. Y is having more friction when compared to x. For x, the friction factor is only 0.2, but for y, the friction factor is 0.3. Okay. Now, then how it is possible for both x and y to cover the same distance in the same time? It is totally impossible. So we can discard this option. C is not the option at all. Okay. Now, the option D is there. At time t is equal to 2 seconds, both the boxes are in the same line. So let us deep dive into the question. Let us try to solve the question. So for that, let me take this data we waited here, and let us move to the next slide, where I will be able to take you to the real situation. Yeah, here it is. Now I wanted to paste it here. I'm pasting the information here. Okay, now it is ready. Now you think about, we shall analyze the situation first. Okay, see, the box is, both the boxes are placed on a slope which is making 45-degree, 1 second, 45-degree with the horizontal. What does it mean? This is 45-degree. That means, see, this is the horizontal line. From the horizontal line, the slope surface is making an angle 45-degree. That is what it means. Okay, it is given in the figure itself. Okay, now this is the slope, angle of slope. And here box is placed like this. The orange color box you are able to see. Now, the weight of the box is acting vertically downward, which is given by mg. Now, by the geometry, it is clear that if this angle is 45-degree, this angle is again 45-degree. Both the angles will be equal. Now, by the concept of resolution of a vector, see, mg, the weight of the box, is acting vertically downward. It is a vector quantity. It is a force, gravitational force. Okay, so that vector can be resolved along two directions. One is parallel to the slope surface, that is this component, and the other one is perpendicular to the slope surface. Okay, now since this angle is 45-degree, the component which is component of mg, which is near to 45-degree, is mg cos 45. This is by the but I am doing this by following the principles of resolution of a vector into its rectangular components. Similarly, the other component which is parallel to the surface or which is perpendicular to this component mg cos 45, it is mg sin 45. Okay, so two components, mg cos 45 and mg sin 45. mg cos 45 is acting perpendicular to the surface. At the same time, mg sin 45 is acting parallel to the surface. And this mg sin 45 is trying to pull the box down the slope. Okay, now, is there any other forces acting on the box? Yes, there are two more forces. The first one, whenever the component mg sine theta tries to pull the box downwards, a friction comes into play. Friction is sliding friction, that is represented by Fk. That is kinetic friction or sliding friction. It is opposing, opposing the object from moving downwards. So that is kinetic friction. The other force, which is normal reaction, this one. Why it is called normal reaction? Because the box is exerting a force mg cos 45 perpendicular to the surface. So by Newton's third law, the surface will exert an equal and opposite force on the box in the upward direction. That is called as normal reaction here. But the effect of these two forces, normal reaction and the mg cos 45, cancels each other. Let me explain that concept with the help of another situation. See, you consider this particular box. I wanted to show you something else. See, one person, he is trying to push the box like this. Okay. Another person is pushing the same box from the other side. Okay. Yes. He is pushing from the other side. Let this person be A and this person be B. Now, A is pushing the box with a force 100 Newton along this direction, and B is pushing the box with the same 100 Newton in the opposite direction. Now you think about it, about that particular situation. What will be the effect on the box? Both the forces cancels each other because both are acting opposite to each other, cancels each other. Now you think of another situation. If B is exerting a force which is equal to 200 Newton here, then what will be the effect? What will be the effect? Here, or let it be for convenience, let it be 150 Newton. Then you will be having a better understanding. 150 Newton. Now, towards this direction, 100 Newton force is acting, but in the opposite direction, 150 Newton is acting. What will be the resultant effect? Effectively, 50 Newton force will be acting along this direction. So, this we need to keep in mind while we are solving this particular situation. Here, see, if n or n and mg cos theta are not equal, what will happen? There will be a resultant force in the direction of the greater force. As a result, either the box will move upward or the box will accelerate downward. But we are not observing both those situations, which clearly indicates that the two forces, normal reaction and mg cos 45, are equal and opposite. That is the logical evidence. Okay. Now, if we consider the forces acting parallel to the surface, we will observe that the box is sliding down with some acceleration. It will increase its speed while it moves down. Okay. Now, we need to consider all the forces. The mg sine theta tries to bring it downwards, but kinetic friction tries to oppose the motion or pulls back the box. So we can equate that equation like this: mg sine 45 minus Fk is equal to the downward force Ma. That is the equation of motion we can write for the box on the horizontal or along the slope surface. Okay. Now, something more we need to understand about the Fk. By the principle of kinetic friction, the kinetic friction is equal to mu k into normal reaction. What is mu k here? Mu k is the coefficient of kinetic friction. And the same is given both for x and y. For x, coefficient of kinetic friction is 0.2, and for y, coefficient of kinetic friction is given as 0.3. Okay. Then we know that normal reaction is equal to mg cos 45. Okay. So by substituting those values in this particular equation, and another thing also we wanted to know the value of sine 45. Yeah, 1 second. That also I wanted to write here. Sine 45, which is equal to cos 45, which is equal to 1 by root 2. This is a trigonometric identity. This also we wanted to know in this particular context. Now we shall put these values, substitutions here. What all substitutions we need at this point of time? The first one is we need to know that sine 45 is equal to cos 45 is equal to 1 by root 2. One thing. Second one, Fk is equal to mu k into n. That means the coefficient of friction into normal reaction. Here coefficient of friction we know for both x and y, that is 0.2 and 0.3. Similarly, normal reaction is mg cos 45. And m is same for both the boxes. So we need not bother about it. And cos 45 is same for both. Okay. So we shall substitute these values in this particular equation. Let me write it here. So mg into sine 45 is 1 by root 2. 1 by root 2 minus Fk is, what is Fk? I am writing the equation for x first. So Fk is mu x is 0.2 into mg cos 45. Mg cos 45 is again 1 by root 2 is equal to ma. This is the equation. Now in this particular equation, we can cancel out m on all the sides. The m is the common factor. We can cancel it out. Now, what is the resultant thing? We will, this is acceleration of x. Okay, max. Okay. Now, we can write it like this. See, we know that the value of g is equal to 9.8 and 9.8 meter per second square. We can approximate it to be 10 meter per second square for the easiness of the calculation in this particular context. Okay. Now, here g is 10. So I can write it to be 10 by root 2 minus the 0.2 into g. 0.2 into 10 is 2. So 2 by root 2 is equal to ax, or ax is equal to 1 by root 2. I am taking out as a common factor into 10 minus 2. What I am getting, 10 minus 2 is 8. So 8 by root 2. That much meter per second square. This is the acceleration of x. We got it. Now we are proceeding, or we are applying the same situation for y also to get the acceleration of y. See here, you remember one thing. Here I am not following any kind of shortcuts. Why? Because a student, in my opinion, a student need to master or follow the shortcuts only after mastering the concepts and having enough practice with the primary level problems. Then only he or she should look into the shortcuts. If you are looking into the shortcuts at the beginning itself, you will miss many things related to the topic. You should undergo, or you should be ready to experience the pressure and pain in the beginning, or it is the pain of creation. So once you experience such a pain of creation, you will start enjoying the process. That will bring you amazing results. That's what I wanted to tell you. I'm not giving some kind of gimmicks to you. I wanted each one of you who are watching this particular video should be benefited, should be able to understand the underlying principles in a clear way. That's my intention. Okay, I will discuss everything in detail. Now, let us consider the case of y also. For y, how can we write the equation? Let me take another color for your convenience. Yes, I will take this color. So again, considering the downward motion of y, we can write mg sine 45 minus fk. Fk is, we know that, see, I will show it again. See, fk is mu k into n. Mu k is, here it is clear that mu y, it is 0.3. 0.3 into mg cos theta. So that is what I am writing down in the equation. So I'm writing it as 0.3 into mg into cos 45 is equal to m into ay. Okay, ay. Now here also m gets cancelled from all the sides. Now I'm writing this equation. Value of g is again 1, 10 into sine 45 1 by root 2 minus 0.3 into 10. That is how much it will be? 0.3 into 10? 3. 3 into, what about cos 45? It is again 1 by root 2 is equal to ay. Again, we get that ay is equal to 1 by root 2 into 10 minus 3. That is equal to 7 by root 2. That much meter per second square. This is the acceleration of y. Now, we have solved only one part of the problem. Now, what are the situations or let me put it in this way. Let us take the questions back. Okay, let me select this. Sorry, second. Okay, let me copy it and let me paste it on the new page. I'm pasting it here. Yes, here it is. You will be able to see the question. Now again, I wanted to write the data we obtained from the previous slide. That is, acceleration of x is equal to 8 by root 2 and acceleration of y is equal to 7 by root 2. That is the result we obtained from the previous slide. See here, yeah, here 7 by root 2 is the acceleration of y, 8 by root 2 is the acceleration of x. Okay, so let us move back. Now, this is the initial situation, and we have already discarded the option C because it will not be correct at any cost. So we discarded the option C. Now we wanted to check both two cases. See, t is equal to 4 seconds is there, t is equal to 2 seconds is there. Here also t is equal to 2 seconds. So we need to check only two scenario. That is, see, both are released at the same time from this position and this position respectively. Okay. Now, after some time, both reached the same line here. Okay. Now, let us take the first scenario. T is equal to 4 seconds. Okay. Now, in this particular situation, see, this is an accelerated motion. Both x and y are moving down with some acceleration, and those accelerations are given by these values, 8 by root 2 and 7 by root 2. Okay, now since this is an accelerated motion and initial velocity is 0, that also we found in the first slide itself. Here it is clearly mentioned. See, both the boxes are released from the same, Rishi places two boxes of equal masses and releases them simultaneously. Yes, yes. Here the sentence statement, simultaneously. Both are released simultaneously. Okay. So let us consider the position of X after 4 seconds. So we are using, see what all things we do have here. We wanted to find out the distance or displacement for X. Okay. Similarly, we have acceleration of X. We have that is 8 by root 2. Then we have T is equal to 4 seconds. Okay. Now again, we have U is equal to 0. Considering the equations of motion, we have 5 parameters: S, U, A, T, and V. Out of these 5, only 3 variables are there. One is displacement, other one is time, and the last one is V. But here A and U are constants. U is the initial velocity, which is a constant. Similarly, A is acceleration, constant acceleration. So both are constants. So there are 3 variables, S, T, and V. Now, in this context, there is no relevance for V. So we need to use the equation of motion without V. Which is that equation? S is equal to ut plus half at square. Okay. Now, this term becomes 0 because u is equal to 0. Now, displacement of x can be calculated as half into acceleration of x. It is 8 by root 2 into t square. T square means 4 square. 4 into 4. Now, see, this 2 will get cancelled here as 2, and this root 2 will get cancelled here as root 2. So the resultant value 8 into 4, 32, 32 root 2. So the displacement of x we will get to be 32 root 2 meter. That's it. Now, following the same strategy for the object y. Now we have calculated for x only. Now we wanted to calculate for y. For y, displacement of y is equal to, again, the term ut, no relevance because u is equal to 0 for both the objects. Okay. Now half into acceleration of y, that is 7 by root 2 into 4 into 4, 4 square, t square. So again, 2 cancels in 4 2 times, root 2 cancels in root 2 times. So 7 into 4, that is 28 root 2. Okay, that is the displacement of y, and this is the displacement of x after t seconds. Now we can look back into the options. First option, what is the option? At time t is equal to 4 seconds, both the boxes are in the same line. See, you think about it. If after 4 seconds, if both x and y are at the same line, what should be the difference in their displacements? Here it is clearly given in the question that initially both x is, the box x is root 2 meter behind box y. So after 4 seconds, if both are at the same line, the difference between the displacements should only be root 2 meter because x is root 2 meter behind of y. Okay. So in 4 seconds, x travels say 10 meter. Sorry, y travels 10 meter, but x travels 10 plus root 2 meter. Then both will be on the same line after 4 seconds. But here, what is the difference? See, x traveled 32 root 2 meter. At the same time, y traveled only 28 root 2 meter. What is the difference here? Difference of 4 meter, not equal to root 2 meter. So the option A is wrong. Now look at the option B. See, both option B and option D are dealing with 2-second cases. Okay. So we need to calculate it again. See, this is a good problem, obviously. But my challenge or my contention is that how this problem could be solved by a class 9 student. I will come to that by the end of this. Okay. So let us proceed with the calculation once again. I wanted to give you the insights. See here, in this second case, taking t to be 2 seconds. What about displacement of x in 2 seconds? Here again, half at square, half into a, or we know at 8 by root 2 into t is 2 seconds in this case. So 2 into 2. So here this 2 cancels out, and this root 2 cancels this 2 by root 2. So what is the result? 8 root 2 meter, the displacement of x. Now, what about the displacement of y in this particular second case? Considering time to be 2 seconds, displacement of y in the second case, it is half into the acceleration a. A is 7 by root 2 into 2 into 2. Again, the same cancellation happens here also, root 2. So the answer here is 7 root 2. 7 root 2. Okay. Now, what we can conclude from this? Let us look back on the solutions. See, we are left with only two options: option B and option B and option D. What does option B says? At time t is equal to 2 seconds, x has traveled a distance of 7 root 2 meter and y has traveled a distance of 9 root 2 meter. It is wrong. We got it. X has traveled a distance of 8 root 2 and y has traveled a distance of 7 root 2 here. Okay. Now, what about D? At time t is equal to 2 seconds, both the boxes are in same line. Is it right? See, what is the difference? See, Sx, 1 second, Sx minus Sy. How much it is? 8 root 2 minus 7 root 2. Or we can take root 2 outside, 8 minus 7. That is 8 minus 7, 1. 1 into root 2, root 2 meter. So it exactly matches with the situation given in the problem. What is the situation given? Initially, the box X is root 2 meter behind the box Y. Okay. Now, the problem, we have solved the problem. The correct option to this particular question, it is nothing but D. And we can apply a trick here. One is we can eliminate C first. Okay. Now I find that we can eliminate the option B also. Why? See, here another logic we can apply, because for X, the coefficient of friction is less, 0.2. And for Y, the coefficient of friction is 0.3. Okay. But here it is given that X has traveled less distance when compared to the Y. It will not happen. So logically, you can eliminate option B also. Okay, option B also you can eliminate, because think in this way. X is suffering less friction. Y is suffering more friction. Then how it will be possible for X to travel less distance within the same time. You think about that. It is also not possible. Okay. So we can logically eliminate two problems, the two options, both B and C we can eliminate. So the remaining options are A and D alone. Okay. Okay. Now we have arrived the solution. Now I wanted to bring you back to another situation. Let me stop sharing this and let me share another screen with you. I wanted to make you realize about our broken education system. Yes, here I am. I hope the screen is visible for all of you. See this. Let us think about the previous knowledge required by a student to solve a problem like this. Let me move this to full screen. Yeah, hide it. Okay. Okay, previous knowledge required to solve this particular problem. See, the first thing, he or she should be knowing about friction. For a 9th standard student, he or she is aware of friction. Obviously, he or she is learning the concept of friction in class 8 or even in the lower classes. But he or she is unaware of the concept of static friction and sliding or kinetic friction. And when it is related to static friction, there is another concept or a special case which is called as limiting friction. And after that only the student is learning the laws of static friction, in which he or she is understanding the concept of coefficient of static friction. And similarly, after getting the idea of sliding or kinetic friction, then only the student is getting the idea of coefficient of kinetic friction. So, if the student is having absolute clarity related to all these topics and all these parameters, like the coefficient of static friction, coefficient of kinetic friction, then only a student will be able to approach this kind of question with confidence and clarity. Then let us look into the second parameter, second previous knowledge. The student should be having clear understanding about the concept of vectors. When it is related to vectors, the student should be knowing the fundamentals of vector algebra. He or she should be knowing how to resolve a vector, how the vector is resolved into components, and how a vector is resolved into the rectangular components. Now again, whenever you are trying to resolve a vector into its rectangular components, what is the importance of direction or angle? What is the trigonometric relations in vectors? All these things a student should be knowing before trying to solve a problem like this. But all these are totally new for a student in class 9th. Then again, coming to the next area, students should be well versed with framing equations of motion meaningfully. All the three equations, S is equal to ut plus half at square, V is equal to u plus at, and V square is equal to u square plus 2as. Some kind of expertise our students are having, but they are not aware of the concept of kinetic friction or static friction and coefficient of static friction or kinetic friction. Without knowing that, how they will be able to frame the equation of motion using the concepts of laws of motion. The student should be able to solve equations of motion based on Newton's laws of motion. See, we have applied Newton's second law of motion in order to obtain the acceleration for x and y. First, step, that was the first step. Then after that, we analyzed the problem, the normal reaction, the state of equilibrium. All these are not given to a 9th standard student with clarity, with clear logical connections. Now let us look into this. See what will be the result of giving these kind of problems to a 9th standard student. Will the student be benefited in some way or other? I think never. Only result is the student will get overwhelmed and get totally frustrated. They lose their interest and they lose their confidence, and they become panic while they approach numerical problems like this. They will think that solving problems like this is a nightmare. It's quite impossible. I'm not good enough to solve problems like this. Actually, it is not their problem. It is the problem of our education system, broken education system. System is expecting results even though the student is having zero knowledge about that. How it is possible? What we are thinking about it? On the other hand, if we are hand-holding our students in a step-by-step manner, in the correct sequential order, we are giving clarity of concepts first. We are helping them to analyze the situation. We are helping them to implement in various situations. Then we are giving numerical problems with lower level of difficulty. Then slightly we are increasing the level of difficulty. Then any student will start enjoying the process. That should be the process. But here what is happening? Then again, they are becoming fearful of examinations. See, we are focusing only on the results, marks, ranks they are getting in the entrance examination. I wanted to give you some more insights. See, there are studies conducted by institutions like premier institutions like IIT Bombay, IIT Delhi, NIT Roorkela, NIT Calicut, AIMS New Delhi, JIPMER Pondicherry, IISER Pune, and several other institutions, including central universities. They have conducted studies on their first year engineering or medical students or research students in the case of IISER Pune. And almost all the outcomes are same or similar. The students are not having application skills or conceptual clarity, or they are not able to connect physics with real life situations. They are well in doing with entrance questions. They have mugged up things. They have relied only on rote memorization techniques. That's the pathetic situation which is happening in our present education system. If the students are given proper foundation, definitely they will be able to create miracles, magics, which will help our country or entire world to progress at a different level. But again, I wanted to say this, our education system is rather broken. So if you want to know more, I would like to invite you to attend my free webinar, which is called Physics Made Easy. It's a 2-hour webinar, free webinar. You can attend the webinar, and I will be sharing several insightful data and studies. You will get mind blown, and you will find something new, something really interesting to proceed with the journey of physics mastery. with easiness, with confidence. So I would like each one of you to register for my free webinar, which is called Physics Made Easy. The link to register for the webinar is given in the description. By clicking that link, you will be taken to the landing page. You will be getting all the details related to the free webinar, and from there you will be able to register for the webinar. So with that, I thought that I think that two things happened today. One, my first live got disconnected due to technical disruptions, and uh, this session became quite some long. Okay, and I uh, I really appreciate and thank. I express my gratitude to each one who attended this particular session, live session, till this point of time. So let me stop sharing this particular screen, and I would like I would like to thank you all once again. So signing off. Bye for now.